So in this lecture we'll discuss about Einstein's photoelectric equation. In this Einstein's photoelectric equation, Einstein used the quantum theory to explain the laws of photoelectric emission, because classical theory failed to explain the laws of photoelectric emission. So Einstein used quantum theory, Planck's quantum theory, and according to Planck's quantum theory, E is equal to h nu, means जो एनर्जी है that consists of radiation consists of packets of energy which are known as photons, and each photon is having energy E is equal to h nu, where h is the Planck's constant and nu is the frequency of each photon. So according to Einstein, when the incident radiation of frequency nu, it is incident on the surface of the metal, then actually in that radiation it consists of number of photons of energy h nu. So actually these are the photons striking the surface. So when the radiation of frequency nu, we are striking the radiation of frequency nu with the surface of the metal, actually the photons are striking with the metal surface. So what a photon will do, a photon of h nu energy, it will be absorbed by the target atoms, or you can say that metallic atoms. After absorbing the photon, a part of its energy, it will be used to free the electron from the atom. हमारे पास अगर एक फोटोन है, we will consider a single photon. वो single photon जो है that will be absorbed by the atom. अब एटम उसके साथ क्या करेगा, फोटोन जो है जिसको एटम ने एब्जॉर्ब किया उसकी एनर्जी का कुछ पार्ट जो है that will be used to free the electron from that atom. And that part of energy which is used to free the electron from the atom, that is known as work function W naught, and the rest of the photon's energy, it will be used in providing the kinetic energy to the emitted electron. जो इलेक्ट्रॉन अब इजेक्ट होगा जब वर्क फंक्शन W naught एनर्जी जो है वो फोटोन लगाएगा उस इलेक्ट्रॉन को फ्री करने में फ्रॉम द एटम, अब वो जो फ्री इलेक्ट्रॉन है, एमिटेड इलेक्ट्रॉन है फ्रॉम द एटम, उसको काइनेटिक एनर्जी कहाँ से मिलेगी, जो फोटोन की रेस्ट ऑफ द एनर्जी है दैट विल बी यूज्ड इन प्रोवाइडिंग द काइनेटिक एनर्जी टू दैट इलेक्ट्रॉन. सो अकॉर्डिंग टू आइंस्टाइन, the energy of incident photon, it does two tasks. One is work function to free the electron, and second is to provide kinetic energy to the free electron. So incident photon की जो energy है that is h nu, work function is W naught, plus kinetic energy of electron is half m v square. Suppose this as equation 1. अब अगर फोटोन की जो एनर्जी है वो जस्ट थ्रेशोल्ड एनर्जी के इक्वल हो, इफ इन केस द इंसिडेंट फोटोन हैज फ्रीक्वेंसी न्यू नॉट, दैट इज if the incident photon has frequency equals to the threshold frequency, then what will be the case? It means now all of the energy of the photon, it will be used to free the electron. क्यों? क्योंकि फोटोन के पास एनर्जी उतनी है जितनी इलेक्ट्रॉन को फ्री करने में लग जाती है. इट मीन्स बाकी की जो काइनेटिक एनर्जी है इलेक्ट्रॉन की, फिर वो क्या होगी, जीरो. सो इफ द फोटोन हैज एनर्जी इक्वल्स टू एच न्यू नॉट, देन वो क्या करेगा, इट विल जस्ट नॉक आउट द इलेक्ट्रॉन, बट इट विल प्रोवाइड जीरो काइनेटिक एनर्जी टू द इलेक्ट्रॉन. मीन्स इलेक्ट्रॉन की वेलोसिटी जो है दैट विल बी जीरो. सो इन दैट केस the whole energy of the photon, that is h nu naught, it will be equal to work function. Why? Because जो plus kinetic energy है that is zero. It means जो work function है that is equal to h nu naught. So now put this value in this equation number 1 and what we will get is the Einstein's photoelectric equation. H nu is h nu naught plus half mv square. So from this we have this equation that kinetic energy of the ejected electron from the metallic surface when the photon of some frequency nu it is incident on it is equal to h nu minus nu naught. Nu naught is the threshold frequency and nu is frequency of the photon incident. And this equation is known as Einstein's photoelectric equation. And now this equation it can successfully explain all the laws of photoelectric emission. So now those laws, they are the conclusions of this equation. So now we will explain those 4 laws by using this equation. See how. Suppose this Einstein's equation, photoelectric equation as equation A. First case, from this equation, now you can clearly see that if in case, why we are saying that in the definition of photoelectric effect that this frequency of incident photon, it must be greater than this threshold frequency, only then photoelectric emission is possible. Why we are saying that? Because you can clearly see from this equation, if this nu means frequency of incident photon, if it is less than the threshold frequency, then the right hand side of this equation will be negative. It means kinetic energy of the emitted electron will be negative, which is not possible. It means no photoelectric emission is possible below nu is equal to nu naught. अगर nu जो है nu naught से less है threshold frequency से, then there will be no photoelectric emission. Now the second case will be when this frequency of incident photon it is greater than the threshold frequency. In that case जो right hand side है it will be positive. It means kinetic energy of the emitted electron is positive. And from this equation you can clearly see that the kinetic energy of emitted electron, it is directly, because h is constant, so it is directly proportional to the frequency of the incident photon. So from this you can conclude this third law, that for nu greater than nu naught, the kinetic energy of the emitted photoelectrons, it depends upon frequency of the incident radiation and independent of intensity. And in case of intensity, as you can clearly see that here only kinetic energy depends upon frequency. It means if you are increasing the intensity of the incident radiation, it means the number of photons, they are increasing in the radiation. If number of photons are increasing in the radiation, it means number of photoelectrons emitted will increase. Because each photon, it will emit 1 electron. So if the number of photons are increasing, it means the number of photoelectrons emitted or ejected, they are increasing. And which will further increase the photoelectric current. So number of photoelectrons emitted, or you can say that photoelectric current, it depends upon intensity and is independent of frequency. And fourth law is, as there is no time lag between the absorption of photon and the emission of photoelectrons, that is why it is known as instantaneous process. So this was all about Einstein's photoelectric equation, which has successfully explained all the laws of photoelectric emission. So in next lecture, we'll discuss about Compton effect and Compton scattering. Thank you.